Hello and welcome to ICSE Class 10 Physics tutorial. The topic is work, power and energy. So before we start, आइए आपको एक शायर की कुछ लाइंस सुनाता हूं. शायर कहता है, दर्द मेरा तू नहीं समझा तो फिर समझेगा कौन. दर्द मेरा तू नहीं समझा तो फिर समझेगा कौन. मेरे हक में तू नहीं बोला तो फिर बोलेगा कौन. मेरे हक में तू नहीं बोला तो फिर बोलेगा कौन. आप क्यों खंजर छुपाकर आस्तीन में लाए हैं. आप क्यों खंजर छुपाकर आस्तीन में लाए हैं. आप तो मेरे हैं, मेरे आपको रोकेगा कौन. आप तो मेरे हैं, मेरे आपको रोकेगा कौन. आईना तो आईना है, सच ही बोलेगा हुजूर. आईना तो आईना है, सच ही बोलेगा हुजूर. झूठ गर कहने लगा तो फिर इसे देखेगा कौन. झूठ गर कहने लगा तो फिर इसे देखेगा कौन. थैंक यू. Okay. The first question is, define work done. So before that, let's understand when we can say that work has been done. Work has been performed in physics. Alright. Work is said to be done when a force applied on a body makes the body move. Or you can say that work is said to be done when a force applied on a body displaces the body in the direction of the force applied. Then we say that yes, work has been done. Okay. Now the first question is, define work done. The measurement of work done. If W is the work done, then we say that W is equal to Fs. In words, work is defined as the product of the force applied and the displacement in the direction of the force applied. So as I told you, W is the work done. If F is the force applied and S is the displacement in the direction of the force applied, then we write W is equal to F into S. Fs means F into S. So W is equal to Fs. Alright? Either you write down W is equal to Fs like this, or you write down W is equal to F into S. Either way, it's correct. Now, what is the SI unit of W, the work done? Just have a look. What is the SI unit of force? Newton. What is the SI unit of displacement? Meter. So Newton into meter is the SI unit of work done. Newton meter, and we call this joule, capital J, joule. And if you are writing in full name, then you have to write joule like this. J should be small. Alright. So finally, what is the SI unit of work done? Joule. Joule. Either you write down like this, capital J symbol, or if you are writing in full, then Joule, joule, where J should be small. Okay. Now the second question is, here in this case, the force and the displacement both are in the same direction. Both are in the same direction. This is the movement, the body is moving like this, and the force is applied like this. So force and the displacement both are in the same direction. Alright. The body is displaced. See, force is applied like this, force is applied like this, and the body is displaced. The body is moving, alright, in the direction of the force applied. So F into S. What will happen? What happens if the force is applied along OA? See this figure. The object is at O, the body is at O, and you have to displace the body from O to B. The body has to be displaced from O to B. But you are not applying the force along OB. The force is being applied along OA. That means theta is the angle between the direction of the force F and displacement S. Between S, the body is being displaced along OB, from O to B, from O to B. The body has to be displaced from O to B. So S, displacement, and F, force, and theta is the angle between them. If this is the situation, then how to find out what should be the formula to find out the work done? Alright. We'll use the basic formula only to derive this formula. W is equal to Fs cos theta, where W is the work done, F is the force, S is the displacement along the direction of the force, and theta is the angle between F and S. Is that fine? Between the direction of the force F and S, displacement S. Okay. What we do now, see, we would like to see the effect of the force F along OB. What is the effect of the force F along OB? What is the component of the force F along OB? How much is the effect of this force along OB? When you are applying force along OA and the body is being displaced from O to B, so how much force is applied along OB? Suppose you are applying a force of 10 Newton along OA. So of course the same 10 Newton force is not applied along OB. So how much is that force? What is the component of the force? What is the effect of the force along? Of course it is not 10 Newton because 10 Newton is along OA. So along OB it will be little lesser than 10 Newton, maybe 7 Newton, maybe 5 Newton, maybe 4 Newton. So that is called the component of the force F. Alright. So that we want to know. And that component of the force multiplied by the displacement is, that basic definition we'll use. The force F, in this case the component of the force, the effect of the force F along S, along the displacement S, multiplied by S itself, multiplied by S. Alright. So work done, comma, W is equal to component of the force F along S, component of the force F along S multiplied by into S. Alright. So this component is F cos theta. The component of the force F along OB, see theta is between F and S, right? So the component of F along OB, alright, covering this theta, is F cos theta. See, I have written in it F cos theta. This is the effect component of force F along OB. This is force only. F cos theta is the force along OB, F is the force along OA, and I'm giving you some additional information. F sin theta, the vertical component. This is the horizontal the vertical component along. I'm just explaining to you. See, this will be F sin theta. This will be F sin theta. F cos theta, F sin theta. Alright. So we are not talking about this. We are not talking about this. Alright. We are talking about only the component of the force. And this is 90 degree. This total is 90 degree. This, if I call this C, then angle BOC is 90 degree. Angle BOC, this full angle is 90 degree. Alright. So this is horizontal component and this is the vertical component. But we are not talking about this right now. We are not talking about this. Fine. We are not talking about this. Only you please understand, F cos theta will be the component of the force along OB, effect of the force along OB, or the force along OB is F cos theta, the force along OA is F, and as I told you, the force along OC will be F sin theta. Fine. So component of the force F along S multiplied by S. Now what is the component of the force along F? Component of the force F along S. Component of the force F along S is F cos theta. So F cos theta is the component of the force multiplied by S, displacement. Same definition, force multiplied by displacement. Force, here in our case the force is F cos theta, because we want force along OB, and along OB the force is F cos theta, which we are calling component. Forget about component. F cos theta is the force along OB. Here F is the force along S, and here F cos theta is the force along S. Here F is the force along S, and here F cos theta is the force along S, along the right, in the direction of the displacement. Fine. So F cos theta multiplied by S is equal to Fs cos theta, Fs cos theta. So we are getting W is equal to Fs cos theta. This is the formula. When the force and the displacement both are not in the same direction. Alright, force is inclined at an angle theta with the displacement. Alright, now in my next lecture, in part 2, I'll be discussing the special cases when theta is 0, when theta is 90 degree, when theta is 180 degree. And I will also tell you that this is the only way to find out the work done. In one book I saw that they have taken the component of displacement. Actually the component means effect. So you cannot take the effect of the body has to be displaced from O to B. So then you cannot say that the component of S is S cos theta along this direction. S cos theta, and then you say that S cos theta multiplied by F, or F multiplied by S cos theta. Because we cannot find out the effect of displacement. You please think, what's the meaning of this, that effect of displacement? So we should not write down the component of S like S cos theta and then say that okay, F multiplied by S cos theta and then Fs cos theta, though the formula is coming correct, but this is not correct. S cos theta, you cannot say that the effect of S is S cos theta along OA. I mean, what could be the effect of displacement? We find out the effect of force. All right. So I don't think this is correct. Though the formula is coming correct, but then S cos theta, writing S cos theta is the component along OA or along F, and then you say that force multiplied by displacement. This is the component of displacement. I don't think this is correct. I don't think this is correct. All right. So the only correct way is F cos theta multiplied by S, and this is not correct. This is not correct. Fine. I hope everything is very, very clear. As I told you, in my next video, part 2, we'll be discussing the special cases when theta equal to 0, theta equal to 90 degrees, theta is equal to 180 degrees. So what happens? Okay. Okay then. Thank you so much. Thanks.